So let's start the backend revision session. Let me check, is it working fine or not? So backend revision is started. So we see, okay. Okay. So the first question arises that what are the different languages present in DBMS? So different languages present in DBMS. So we have to know what are these languages we used to study in DBMS. So so let's see. There is four type of language in DBMS. First is data manipulation language and data definition language and data control language and transaction control language. Okay, so let's briefly understand or briefly discuss this topic. This is type of languages of DBMS. Okay. Language. First one is first one is um, okay. First one is uh, data definition, DML. So DML stands for the data data manipulation language. Data manipulation language. Okay. After after that, we have to study. We have to study data data definition language, DDL. Data definition language. After that, have to know we have to know about DCL, data control language. Data control language. After that, we have to know about TCL, right? TCL, transaction control language. So the first thing is data definition. Let's know about data definition language. DML, DML person equal to. So it is used to manipulate. So it is used to manipulate. So it is used to manipulate the data and consists of the command for the same. So select, insert, delete, and update are data manipulation language. And the data definition language, it is used to define and update the data. Data manipulation is manipulating the data. So in which we have to select the data, insert the data, delete the data. In data definition language, data definition language, in manipulation portion, like select, delete, and update things are update. These are things are covered inside DML. And when we are data definition language, we have to define the language. So it is used to define and update the data. So define the data. So definition portion will be done by data. So definition portion will be done by the data definition language. So here is the truncate portion, alter, and drop drop and create or renames. These are the data definition. Create and truncate, alter, drop, create and rename. These are data definition language. After that, we have to see the DDL, TCL, like TCL, data control language. Data controlling the data. Controlling the data is like it control and access the data. Control and access the control and access the data. Okay. How we control data through grant and revoke portion. Manipulation, select, delete, and definition is truncate, alter, drop, and this or data control language control and access the data, providing grant and the revoke portion. Okay. After that, TCL is called transaction control language. So it is used to handle. Okay, wait a second. It is used to TCL. It is used to handle the. So it is used to. Okay. So transaction portion. It is used to handle the data transaction. Handle the. Okay. What? Handle the data transaction. Handle the data transaction. Okay. So data transaction handle can by the commit, rollback. Okay, these are the language. These are the language. These are the language present in the DBMS. Okay. So next, move forward for the next question. What is the acid property? So first question is completed. So first question is completed. What is language of DBMS? Language of so languages of DBMS. Okay. After that, second question. Second question is what is the acid? What is the acid property? Acid property. So we learn about the acid properties. So let's see acid properties. Okay. So acid properties. So acid properties are set of properties that ensure the reliable and secure transaction among data and databases. So property ensure that the reliable and secure transaction on databases. To maintain the data consistency, acid properties are followed. ACID stands for the atomicity, consistency, isolation, and durability. So let's see. Uh, let's see what is so acid acid stands for what? Acid stands for atomicity, 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 consistency, isolation, and last D stands for durability, 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 durability. Okay, access stands for, and it is the actually the acid stands for what is said. Acid acid is a set of property that ensure the reliable transaction. Ensure the reliable and secure transaction among reliable reliable and secure secure transaction between databases. Okay, databases defined as acid properties, acid properties, and acid properties, and acid stand for the atomicity, consistency, isolation, and durability. So what is the uh, what is atomicity? Atomicity. Atomicity means that entire either the entire transition take place or at once or not all. मतलब, yeah, or nothing, all or nothing. In simple word, you have to all or nothing. Okay, atomicity. After that, atomicity means that if a transaction happen, the transaction happen from one database to another database. There is no partial, there is no full like that. If either the transaction happen, all the data move forward. If not, they will be stay in the previous data set. After that, we have to consistency. Consistency means that the data must be consistent before and after transaction. Remain same. In simple, but remain same. Before and after the before the transaction and after the database remain the same. There is a databases remain the same before and after transaction. Okay. After that, we have to learn about isolation. Isolation. Isolation mean isolation mean that isolation mean that no transaction can either the data in no transaction can alter the isolation means when a two transactions occur simultaneously. No data can alter the other data. In which when we are depositing the money in a bank or we are withdrawing the money is not from the one person by the other person. It does not affect any databases. So no difference, no interference, no interference. In the interference between them. Isolation means no interference. Both transactions happens simultaneously. And after that we have durability. Durability means uh, the transaction made should be durable and must be persistent. Must be durable and persistence. The transaction remain be durable and persistence and persist. Okay. Atomicity. So we have learned it is a reliable and secure transaction between data set. Atomicity stands for the atomicity. Acid properties stand for the atomicity, consistency, isolation, durability. Atomicity means all and nothing. Either the entire transaction take place at once or at all. Consistency. And the database must be must be consistent before and after the transaction. Actually, no transaction can alter the data during the transaction. Okay, and transaction made should be durable and persistence. Okay, we move forward for the third question. Normalization, normalization, okay, and normalization and its type and its type. Okay, third question is normalization. What is normalization? So, normalization is a technique that reduces the data redundancy and eliminate the insertion, aberration, and deletion anomalies. Normalization is a process of dividing the larger data set and larger table into the smaller table and linking them with the relationship. It is a process of organizing the data into the databases. Okay. Okay. Normalization is a technique that reduces the data redundancy and eliminate the data insertion, updation, and normalization is a process of dividing the data table into the and smaller table and smaller table and link them through a relationship. It is a process of organizing a table. So normalization, normalization. normalization. What do you mean on normalization? It means that reducing the data redundancy and eliminate the updation, insertion, and deletion anomalies. Okay, now yes, and the and also in another word we can also say that it is a process. It is a process of process of process of dividing dividing the larger data set into smaller one. Okay, so reducing the data redundancy, eliminate the update, insertion, and deletion anomalies, and process of dividing the larger data set into the smaller data set and linking through a relation and linking linking through some relation. Okay, and is a process and it is a process of organizing the data set. It is in simple word the process of organizing organizing the database or a data set. Okay, and reducing and the insertion anomaly. And so let's discuss about three type of anomaly occur in this. So insertion, deletion, updation. So insert, what do you mean insertion? Insertion anomaly is when one cannot insert a new tuple into relation due to the lack of data. Now, matlab, in a one cannot insert any data due to lack of data. Okay. Deletion anomalies is where a deletion of data result in the unintended deletion. Deletion of data uh, deletion of data result in an unintended loss of some important data. And updation anomalies mean updating anomalies is when update a single data value require multiple rows data to update it. Okay, and the types. Let's discuss the types types of normalization. Normalization. Okay, so first one is 1NF form. Okay, a 2NF form, 3NF form, 3NF form, 3NF form, and 3NF one and BCNF. After that, BCNF, 4NF, 4NF form. Okay, and if for the further study, there will be 5NF form. Okay, so let's discuss one by one. What is 1NF form? So 1NF form is known for the first normal form. A relation is said to be that 1NF if it contains an atomic value. There must be contain an atomic value. And 2NF form is known for the second normal form. And a relation is said to be 2NF if it is in 1NF. The primary condition for the further NF form is to having the previous NF form in it. So for in 2NF form, it must be in 1NF form, and in a relation is said to be 2NF form if 1NF and each non-prime attribute is fully functionally dependent on the primary key. Fully functionally dependent on the primary key. In 3NF form, it should be in third normal form, and the relationship said that there is no transitive dependency. If transitive dependency is occur, so it is in the inner form. And after that we have B, C, and F. known as voice code normal form, which is a strict version of 3NF form. Relation is said to be 3NF form if it's is in the 3NF form for the every functional dependency like X is related to the Y. So X is a super key of the table. It also be in 3.5 3NF form. Okay, is functional dependency. Every functional dependency is a voice code. It is strict version of 3NF and relation set to be 3 if it is in 3NF and the every functional dependency and X is the super key. So after that we move forward for the 4NF. It is known as fourth normal form and the relation is said to be 4NF form if it is in the BCNF form and there is no multi-valued in a table. There is no multi-valued in the table. Okay. So let's move forward for the next question. What is ER diagram? What is ER diagram? So let's see. What is ER diagram? ER diagram. ER diagram. So ER. So ER diagram. So ER stands for actually the ER stands for the entry relationship diagram. Entry relationship E stands for entry, R for relation for entry diagram. Entry diagram display the different entity and relation among them and stored inside the database. The different entities and the relationship among them and stored in a database. ER diagram provide a logical provide a logical structure of the database. Creating ER diagram of the database is a standardized procedure and it is done before implementing the databases. So, okay. So ER stands for the entity relationship 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 diagram. And what is it is diagram? This is the relationship between entity and among their database. Entity and it is a different entity and relationship among databases. Entities relationship with the databases. Okay, and it is a logical extension and a logical structure of the databases. So logical logical structure of of databases. Okay, logical structure of the databases and creating the ER diagram before standardizing and before implementing the databases. So we are creating the ER diagram before and creating our new databases and in so ER diagram is based on three components. It's based on three components. Based on three components. Three components. So one is entities, entities. Okay. After that, attribute, attributes, and relationships. Okay. So entity it can be what is entities. So entities it is defined as the object having some property. It is a real real object, yeah, object having some property. They are represented as a rectangle. So entities are represented as a rectangle. Attribute the properties of attributes is defined as a attributes but property of that entity. Okay, like that entity is defined as rectangle and the properties attributes are defined as ellipse. There is no word. So this person is ellipse is noted as a attribute and relationship between denoted by the line using a linear arrow. So this portion defined as a this. So this is entities. This is attribute, and line define the relationship between them. So ER diagram stands for entity relationship diagram, entity diagram that display the different entities and relationships among them stored in a database. ER diagram provide the logical structure of the database. Creating the ER diagram of databases standardize the procedure and it done before implementing the databases. Okay. ER diagram is based on three things, three concepts. So entities, attribute, and relationship. Entity is a real object having some property, and the properties of that entities is known as attribute, and the relationship how entities are related to each other, how entities are related between each other is known as relationship. So let's take a break.